everybody and welcome back to another video. In this video, I will be covering taking a sine of a cosine inverse. Or you could do this with a cosine of a sine inverse or a tangent of a cosine inverse. In other words, a trigonometric function of an inverse trig function. Now to begin, let's just draw out a triangle over here. We will make this a right triangle. So this right here is 90 degrees, and this, let's call this theta. So let's say that our angle theta is equal to the cosine inverse of 6 divided by 11. Now, if we remember from our so, ka, toa principles, our cosine is equal to our adjacent over our hypotenuse. So this would be cosine theta is equal to our adjacent over our hypotenuse. And if you take the cosine inverse of both sides, you get that theta is equal to cosine inverse of your adjacent side over your hypotenuse. So this is what we have right here. Theta equals cosine inverse of 6 over 10. So this is our adjacent side and this is our hypotenuse. Our hypotenuse is 11 and our adjacent side is just 6. So this is 6 and then 11. So now we are looking for this side right here. Let's call this side x. So we know that c squared is equal to a squared plus b squared. And in this case, c is 11, which is equal to our x squared plus our 6 squared. So this implies that x squared is equal to 121, which is 11 squared, minus 36. And if we take the square root of both sides, we get that x is equal to the square root of 85. So this is the square root of 85. Now, we are looking for the sine of cosine inverse of 6 over 11, which is just sine of this theta right here. So sine is equal to our opposite side divided by our hypotenuse. Our opposite side we can see is now just the square root of 85. So this tells us that sine theta is equal to square root of 85 divided by 11. And since theta and cosine inverse of 6 over 10 are the same thing, we could say that this is equal to the square root of 85 divided by 11. And this is our final answer. So I hope you enjoyed this video and learned a lot, and thank you for watching.